Modeling and optimization. So all this time in the first semester, all we did was find derivatives. Okay, no yawning, that's a demerit. And whenever your derivative went from positive to negative, I knew that the original function had a max, because that's the definition of a max, right? And whenever the derivative went from negative to positive, I knew that the original had a min, because that's the definition of a min. So that's all we're doing. We're either maximizing area, maximizing volume, or minimizing one of the two, or minimizing material used, or maximizing profit, minimizing. So you can see how this is used. I even put a business calculus question. Look, I put a box question, get the max volume, and I put a can question, get the dimensions for the most volume with the least amount of surface area. And then I put a business calculus question. This is your average cost, and then we put the amount of the maximum area with the least amount of fencing. Look at all these application styles. So now you're seeing how the derivative could be used in real life, like, you know, for real cool stuff. All right, let's start with the basics. Example 1, find two numbers whose sum is 20 and whose product is as large as possible. So we talked about this a little bit yesterday, guys. So we're going to say x is a number, y is a number, and sometimes they call this the restriction equation. So two numbers added together give you 20, sometimes called the restriction equation. And then what do we want? We want the maxest possible product. The product as large as possible. So product equals x times y. And I'll wait for that, Bill. This is what I want the max of, so that is what I'm going to take a derivative of. We're not going to use, well, I mean, I guess you could use product rule, but don't take a derivative with two letters. We're taking the derivative with respect to one letter. So what you do is you take your restriction. Yeah, no yawning. That's another demerit. Man, demerits everywhere. No, being ninth period is tiring, guys. I get it. What you do is you take your restriction and you solve for one of the variables. It doesn't matter which one, but you guys usually like to solve for x or to get y by itself, right? So y equals 20 minus x. So that means my product is the same thing as x times 20 minus x. And then what I would do is I would just distribute. So my product equals 20x minus x squared. And I think last time maybe we held it like that. So are we okay so far? Nothing crazy, right? Again, what did I say? This is what I want to maximize, so that is what I'm going to take a derivative of. Whatever you want to maximize or minimize is what we're taking derivative of. Does that make sense? So here we go. P prime, what's the derivative of 20x? 20 minus the derivative of x squared? 2x. And now what you're doing, you're going to solve for a critical number to see if that critical number is a max or a min. So let's see. So 20 equals 2x. I just moved the 2x to the other side. Divide both sides by 2. And then that means 20 divided by 2 is 10. So x equals 10. And then I do my little number line really quick. F prime. And I put a 10 here. And all I'm doing is checking to see if I really go from positive to negative. If I put a 0 into this expression that I'm underlining in sky blue, 2 times 0 is 0, 20 minus 0 is 20, 20 is a positive number. If I plug in a 12 or a 20, 2 times 20 is 40, 20 minus 40 is a negative number. So I know that I have a max at x equals 10. What has a max? Well, if I put F prime there, but P prime. This is P prime. P has the max. Yes. Yeah, no, this is just, I'm just deriving to verify that I really have a maximum there. Because remember, if I have if my slope is positive, that means my function is increasing. If if my slope is positive, and sorry about the squigglies, if my slope is positive, my function is increasing. If my slope is negative, my function is decreasing. Oh, look, where's the max? Whenever the derivative changes from positive to negative. Whenever my slope changes from positive to negative. So that's all I'm doing. I got a 10, so I'm going to plug in that 10 in here. So P equals 10, and then 20 minus 10 is 10. So my maximum product is 100. Does that make sense? When you guys were in algebra, you can probably do it with algebra. You can just probably go y equals, and then just type x here, and then 10 minus x. And then I think we discussed this last time. And then window 0 to 20. Okay, yeah, graph. That sucks. Let me make it where I can see y scale. Let's go by Let's go by 5. Oh, no. Window. Oh, yeah. 0 to 10. X scale by 1. Y min negative 10. Y max 150. Y scale. Why did it look like that? It was not 10 minus X?
It's 20.
Oh, no wonder. It was all wrong, guys. Yeah, you guys got to tell me. I don't know. 20 minus X. And now that will fix everything. There we go. And here I was thinking, like, man, what the heck? 10. All right, there we go. Check it out. This is the output. This is my product. With algebra, with no calculus, you can just tell the calculator to find where the max is at, and it's at 10, right? Second, calculate, look, maximum to the left of this. I know, it sounds redundant because we kind of already know this. To the right of this, enter. Look, it says maximum 10.0001, max product 10. But look, if I were to put the derivative, so let me turn this one off. What was my derivative? It was 20 minus 2x. So notice, remember guys, there's my derivative. So I just care about where across the x-axis. So I'm going to put negative 10 of 10. Look at this. It crosses, this is my derivative, that red line. It crosses the x-axis at 10, and it goes from positive to negative. So at x equals 10 is where I must have a max. What's up?
Does it make a difference from yesterday when we plotted it?
The tolerances in the calculator, that's all that's happening. 9.9999999 forever is 10. And 10.000001 is 10. It's the tolerances. When it executed, maybe it executed at a certain location, and when it was bouncing back and forth, it was bouncing on the right side of 10 instead of the left side of 10. So it's just the programming. So cool stuff, right, from engineering? Okay. Oh, okay. I thought it was cool. All right. Here we go. This question. Here's where we really left off. And I think we already kind of figured it out. So I'm going to go slow, as slow as I can. A rectangle is inscribed under one arc of the sine curve. What is the largest area the rectangle can have, and what dimensions can give you that area? So I'm going to draw a sine curve. There's my sine curve. I'm going to put the points that I know are definitive. It's not the best drawing, but that's fine. Oh, I already started there. I know that's at pi over 2. And I know this point right here is pi. Here is my rectangle. I can draw a rectangle however I want. I don't have to draw that rectangle. I could have drawn it right here like that as well. Yay or nay? Okay. I want what will give me the biggest area for that rectangle. The biggest area. So here we go. I'm going to say area of a rectangle is length times width. And we know that for a fact, right? Okay. I'm going to call, what do you want to call the length? The x-axis or the horizontal displacement or the vertical displacement? Horizontal displacement? Okay, so I'm going to call this the length. Let me choose burnt orange. I'm going to call this the length. And I'm going to call this, do I have another color? Let me erase this purple one, or the sky blue one. And I'm going to call this sky blue one, I mean, I guess I can pick any color by just clicking on the little, I'm going to call this the width. Are we still okay? Okay. This curve is y equals sine x. Okay, so don't worry, guys. You don't have to write right now. Let's just take this all in. Do we understand that the width of this rectangle is dictated by the height of the sine curve? So I can say that the width, and don't worry, I'm going to give you guys time to write, that the width is equal to sine x. Are we cool with that? Okay. Now, yesterday, Flores told us that this distance here okay, let me go to my little color spectrum. Let's choose green. That this distance here was just some x value. That's just some x value. correct? And because of symmetry, this is another x value. It's that same, but what I mean another x value is it's the same magnitude. Whatever this magnitude is of this line, it's the same magnitude for that line. Cool or not cool? So that means, look, I already know the distance from the origin all the way to this point. I know that that distance has to be pi. So then that means I can say that the length is nothing more than pi minus, well, that's an x and that's an x. How many x's do you have? Pi minus 2x. Perfect. Does that make sense to you guys?
How does width equal sine x?
No. Width is sine x. Yeah, I thought you were talking about length. Width is dictated by the height of that curve. Well, look at the height of that curve. It's on the curve. The height of the rectangle is on the curve. So if I have a rectangle here in black, check it out. Sorry, man. Sorry that I gave you the look of like, what are you talking about? If I have this rectangle like this, notice that this vertex or this coordinate is right on that red line, on that red curve. And that red curve is sine x.
Oh, okay.
That makes sense?
Yeah.
Okay.
I was like,
Yeah, I'm sorry, miss. It took me a while to process. I was like, what are you talking about? Okay. Yeah, I know. I'm sorry. I'm sorry, miss. I'm sorry. Don't cry. We're good. We're good. No. Stop. Okay. All right. Here we go. The area of that rectangle now, in terms of, I like that red, is equal to pi minus 2x times sine x. Are we okay? All right. A restriction equation. Let's see. What's my restriction? Okay. The length has to be between, let's see, if I max out, actually I should say, because there is a restriction. If I'm way over here at these vertices, and I have a length of pi, but I don't have any height. Does that make sense? And if I'm right here, then that means I don't have a length. My length is 0, but my height, so I don't have any area anyways. So what I'm trying to say is, okay, we'll talk about the restriction one later because this one's probably not as easy to see. Oh, you know what? It's easy. Okay, I'll just say it like this. Yeah, I know, guys. I know. I'm not making it easy. X, the biggest or the smallest, quote unquote. I say biggest because it's also smallest, but it's because it's their inverse operations, right? If you're 0, that means your length is largest. X has to be between 0 and pi over 2. Those are my extremes. That's for X. Let me go right there. If X is 0, that means this green line here is right there at that dot, and that means that length is pi, but that means I don't have a rectangle because this purple line up here is right on the x-axis. So there's no area. Does that make sense? If X is pi over 2, that means, imagine I continue to make X closer and closer to this. Both of them like that. So then you start getting a taller and taller rectangle. You guys see that? And if you are right at the pi over 2 mark, I don't have a rectangle. It goes away. So I don't know, maybe I should take away the equal signs. But if I put the equal signs, my area is 0 on both of them, at those both extremes. So here's what I'm trying to say. Because my area is 0 at both of these extremes, whatever critical number I get, if I just get 1, that must be a max. It must, because the other 2 are zeros. Does that make sense? My other 2 extremes, my area is 0s at those 2 extremes. So then that means if I get 1 critical number, and only 1, that must be a max. It must. It must. So let's find a critical number and see what it is. And I'm going to write that down right now. Because a of 0 equals 0, and a of pi over 2 equals 0. If I get 1 critical number, it must be a max. Because of this. If 1 critical number, comma, must be a max. If you get 1 critical number, it must be a max. Because at the 2 extremes, I get area of 0. Sine of 0 is 0, sine of pi over 2 is 1, but 2 times pi over 2 is pi, pi minus pi is 0. How do we feel? All right, here we go. Let's get our critical number. I'm going to find a derivative. This is what I want to maximize. That's what I want to maximize. That's what I'm going to take a derivative of. Does that make sense? So I'm going to write a prime equals first pi minus 2x times the root of the second. What's the derivative of sine x? Cosine x plus second sine x times the root of the first. What's the derivative of the first? Negative 2. I'm going to equal that to 0. And let's see, can we do it with basic algebra? I'm just going to use the calculator. Good thing we have a calculator. So I'm going to type it in like this, actually. Pi minus 2x cosine x minus 2 sine x. I'm going to type this expression into my calculator. So take your calculator. Clear. I already forgot it. What did I have again? Pi minus 2x, close, cosine x, close, minus 2 sine x, close. Okay. All you care about is where you cross the x-axis. This is my derivative. And it is going to cross, I guarantee you when I plot it in a little bit, it is going to cross from positive to negative because it's a max. It's the only one. Cool or not cool? Let's click on window. Remember that the most extreme value for x is 0, and the most extreme value for x, again, the smallest is 0, the biggest is what? Pi over 2. So I'm only going to look between 0 and pi over 2. X scale by 1, that's fine. Y min, I only care about where I cross the x-axis, so I'm going to go from negative 3 to 3. Actually, we can even go closer than that. Negative 2 to 2. Y scale 1. All right, here we go. There it is at that value. How do I find it? Second, calculate number 2. Left bound, enter. Right bound, enter. Make sure you practice, guys. And there it is, 0.710. So at that x value, this equals 0 at x equals, oh man, 0.71046. 0.71046. Oh, okay. They're having a good time over there. All right. What does that mean? Child, you don't give me, I don't have dimensions. Let me, what was the question asking? What is the largest area of the rectangle can have and what dimensions give that area? Okay. So here we go. Let's find the largest area and let's give the dimensions of that rectangle. So the largest area, this is my x value, right? Don't try to memorize it. Don't truncate it. Store it in your calculator. Here's how you do it. Practice with me, guys. Go to the home screen. Push X. I just like to push X real quick just so I can verify that that is the same value. Is that the same value that I had? Yeah. Push store. That's next to the number 1 button. And then store it to whatever letter you want. I just like to go down the alphabet, so I'm going to go to store it on A. Yeah, just push X. By the way, the X is next to the alpha key in the top. Don't go alpha X in the bottom. Are we okay so far? Oh, yeah, ask me. Yeah, ask me. Oh, look, it's going to highlight when I push it in here. You see, there it is. You see that red button?
Well, yeah, but like, how did you get the number to X?
Oh, okay. Let's start again. I got it like this. You see, when you have to do this first. If you don't do this first, it won't store it. So when I go here, second, calculate, I push the number 20, and it says left bound. You go to the left. Right bound, I go to the right. Guess. No, I don't want to guess. There's only 1. And there it is. See how it says in the bottom X is something and Y is something? So now those numbers are stored temporarily in the registers for X and Y, the way the memory works in the calculator. So now if I go to the home screen, put second quit. Here is my home screen. And now if you just push the X button, boom, 0.710. And then what do I do if I want to store it to a letter permanently so I don't mess it up or override that X value? You push the arrow button, second A, enter. So now it's on my A. Cool? All right, here we go. I'm going to get the length, and I'm going to get the width, and I'm going to get the area. So what is the length? Well, according to this, it says that length is pi minus 2x. So I'm going to go and I'm going to write length equals pi minus 2 times 0.71046. I guess if you write a letter here to equals a, you can write 2a. And my length equals, I go to my calculator. I'm going to go pi minus 2 alpha a. 1.72066. 1.72066. What is my width? Well, my width is, where's my W? Oh, it's just sine x. So sine of 0.71046. Now remember, that keeps going forever. Don't round it. Just use your calculator, guys. So I'm going to take my calculator, and I'm going to go sine of alpha A. 0.65218. 0.65218. I don't remember if I wrote the formula onto y1 or not. Did I? No, that's my derivative formula. Okay, no problem. All right, here we go. What is the maximum area? You just scroll up. This is my length. Which one's my length? This one right here, right? 1.72. That one times, this is my width. That one, enter. 1.12219 is max area. Excuse me. So, sorry guys that it's all. Max area is, I took this number, there it is, 1.72066, and I multiplied it by 0.65218, which equals 1.122. 1.122. How many digits after the decimal? Always 3. Don't round until the very end, or truncate until the very end. By the way, if in case you're wondering, Chop, couldn't you just have put your x value in here? Yes, you better give you the same thing. If it doesn't, then there's something going on. There's magic. Let's see. Pi minus 2a. Look, it's going to be the same, guys. Times, and whether or not times sine a, because that's what my formula is, right? That's what this is, see? Pi minus 2a times sine a, and a is the x value where I got the max. And look, it's the same thing, digit per digit. It should not be any different. How do we feel? Yeah, maybe I gave you guys too hard of a question too quick. I should have probably done lighter questions, man. Okay, so I might have to do a version 3 where I do easier questions. Okay. This one's an easier question. I should have put this one first. You can read that too if you want. I got it from Demena. Look, I'm formatting. I'm putting where I'm getting my sources from. So Grajeda would be proud. Hey Grajeda, if you're watching my video, you know what? I'm going to forward it to you, Grajeda, and I'm going to tell you to go to the 2 minute and 36 second, oh, not 2, it's 2:36. I'll tell you to go to this timestamp. Okay, you guys ready? All right, here's what we have. Let's read it. Example 3. An open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin and bending up the sides. See figure below. How large should the squares be to make the box hold as much as possible? What is the resulting maximum volume? Okay, do we understand what's going on in this question before we start? This is a really good engineering question. And it's okay if you don't. Read it again. I'm going to come over here so I can explain. This box is going to change dimensions depending on x. Do I want a short but tall box, or do I want a large base but short box? Look, guys, if you cut this square on this corner larger, then this box will be higher. Then it'll be slimmer. Do you guys see that?
Yeah.
So I want, you're the engineer, you're the one that's designing this. I want the maximum volume for a 20 by 25 sheet of tin. And you're designing this. You think you can do it if you're that engineer? Yes, yes you can. Yes you can. Look, now you're seeing why this is so useful. Look, it's open top. So notice the edges. You're just one sheet of tin, and all you're doing. I see it all the time in Peter Piper Pizza or Domino's. They just fold in but that's a closed top. But yeah, look, it's open top, and all they do is just close it. Of course, those little square X squares or the little squares there, that's just discarded. That is taken into account. If you're an engineer, you want a little waste as possible. But we're basics right now. We're rookies, so we got to do the rookie problems. Are we okay so far? All right, so here we go. How do I find, I guess first and foremost, what do they want to maximize? Volume. So I need an expression for volume first. How do I find volume of a box or rectangular prism? Perfect. So I'm going to come right here and I'm going to write volume. And I'm going to write what it is. Length times width times height. So I'm going to go length times width times height. And if you want, you can say in the corner, what is your length, what is your width, what is your height. So here we go. Length equals. If you fold up these edges, so look, the pictures are here. If you fold up these edges, that's an X, that's an X. So this distance here, look, notice from here, okay, I guess I'll write it. That distance here, if you want to call that your length, notice that is currently the way it sits, that's 25, because it's a 25-inch box. Yes or no? Now notice if you cut this little piece, that's an X, and you cut this little piece, that's an X, then I no longer have 25. What did you just cut out? You cut out 2X. So my L, the expression for L of this box is going to be 25 minus 2X. Do we see how we did that, guys? Okay. Same deal for let's use purple. Same deal for this. This distance in purple, we're going to call that what? The width? That distance in purple should be 20 inches. Well, it is, right now it is 20 inches. And then this in burnt orange is X. And this in burnt orange is X. So that means I got to do 20 minus what? 2X. That's your expression for that width. And then your height is just dictated by what? Look at this three-dimensional one to help you out. What is the height? The height is just X. Height, X. How do we feel? Nothing crazy. Perfect. So here's my volume expression. Volume equals the length is 25 minus 2X. Close it. The width is 20 minus 2X. Close it. And my height is X. How do we feel? There is something called the triple product rule. We're not going to use that. I mean, there's a product rule, but this is what I want to take the derivative of, right? So you have to use algebra. So we're going to use algebra to FOIL it before we can take a derivative, because it makes life easier. Here we go. I'm just going to worry about these two right now, and then in the very end, I will multiply by X. Yeah, what's 25 times 2? I don't know, Chop. 50. So 25 times 20 must be 500. See? 25 times 2X. Yeah, I wrote minus 50X. 2X times negative 20. Negative 40X. Negative 2X times negative 2X. Perfect. Remember, don't forget, you still have an X on the outside. I'm going to go ahead and distribute that X, and I'm going to write the highest degree in the front because I like to have the highest degree in the front. My volume expression is 4X cubed, and then I'm going to combine like terms. What's negative 50 minus 40? So negative 90X squared, when I multiply by that X, plus 500X. Are we okay so far? All right. This is what I want to maximize. What do you want to maximize? Say volume. This is what I'm going to maximize. So because this is what I want to maximize, this is what I'm going to take a derivative of. Good job. We're getting it. So I'm going to write V prime equals, let's take the derivative. What's the derivative? 12x squared minus plus 500. I'm going to equal this to what? 0. I don't know if I can factor this. You can probably factor. I see they're all evens, but it's probably easier to just use your calculator. You guys ready? Here's how you do it. What rule do I got? It's a quadratic. So what formula can I use to solve for x? Quadratic formula. Do you remember the quadratic formula?
positive, negative. It's like
Here it is. Side note, write this down. Ax squared plus bx plus c equals 0. You can always use it for this. And to solve for x, you do this. X equals negative b plus minus square root b squared minus 4ac all over 2a. Yeah, there's a song. There's a song. Oh, there was a very negative boy who was undecided about going to a radical party. He was a square boy. Okay, never mind. All right, here we go. Yeah, it is. It's a little story. Okay, we ready? All right, so here we go. My A is 12, your B is negative 180, and your C is 500. Now, YouTube, before you start throwing some hate, yes, I know that we could have reduced it, but we're just going to take it and go right into it. All right, here we go. X equals positive 180 plus minus square root, parenthesis, negative 180 squared minus 4 times 12 times 500. All this is over 2 times 12. Do you got to do anything by hand? No, you have a calculator. I'm going to show you how to type that in. Take your calculator. Here we go, and I'm going to go slow. I'm going to clear everything so everything's simple. Push the alpha, and in mine, you can either use, it's actually right next to it, or you can push the Y and push the enter on that. So you have a nice little fraction, so no one messes up. You can actually also push alpha and then the X, because I see it up there also. Cool or not cool? All right, here we go. What did I put, negative 180 or 180? 180, and then I'm going to do the plus one. You can't do both at the same time, so I'm going to go plus, and then put the square root. Make sure to put it, if you're going to put a negative, put it in parentheses. Okay, let me tell you what I used to tell my kids. I used to tell them to forget the negative and just put the number squared. Anytime you square a number, will it ever be negative? No. But if you're, because some of you are going to forget, if you put the negative and you don't put the parenthesis, the calculator keeps it a negative. You know that, right? Okay, so make sure, if you're going to put the negative, make sure to put parentheses. Put a square on it. Minus 4 times, what was my A? 12, and the C was 500, right? Yep. Okay, and then, was it a positive 500? Positive. Okay, and the bottom 2 times, what was my A again? 12. All right, push enter. That's a possible answer, and we'll talk about the uniqueness of our answers. So 11.3188. Store that to A just in case. Store alpha A. All right, so let me come over here and I'm going to write X equals, give me that number again, guys. 11 point what? Okay, I'm going to call that X1. X2. I'm going to do the same thing, but instead of a plus, I'm going to put a what? Minus. You don't have to type it again, guys. Just scroll up. That's what's beautiful about these calculators. Scroll up and then just go to the plus sign and change it to a minus. There it is. What is the other one? Yeah, give me more digits. 4 1? 1 1. 3 ones like that?
No, just 2 1.
Okay. 6 8 1 1. Okay. I'm going to store this to be. One of them I can use and the other one I cannot. And maybe this is what I should have mentioned about that restriction one. Okay, which one can I not use and why? Focus, yeah. No, yeah.
Okay,
Tell me.
one, because you can't get a negative number and multiply 11 by 2.
Perfect. These are the restrictions, guys. Look at the smallest one. You see this 20 minus 2x? The restriction for, what did I call that? The width? The restriction for the width. So I'm going to come over here. 20 minus 2x. So the biggest x can be, this is my restriction. The biggest x can be is 10. 2 times 10 is 20. And the smallest x can be is 0. And I guess if you're talking about if you want a box, then you can't even be 10 and you can't even be 0. So what I'm trying to say is because of my restriction of x, My volume at 0 is 0, and my volume at 10 is 0. So I already know I cannot be bigger than 10, and I cannot be smaller. You can't have a negative value for x. So I already know that this value there must give me my max. It must, because that's the only value that's between 0 and 10. Does that make sense? Okay. Now, we still got to answer the question of what is this max volume. So this is the one we're going to use. We stored it in B. Remember that we stored it in B. And now we're just going to plug in to see what our dimensions are. They wanted the dimensions, so let's find out what the dimensions is. So I'm going to go to my home screen. Length equals 25 minus 2 times 3.6811, and that equals, so 25 minus 2b. 17.6376. 17.6376. My width equals 20 minus 2 times 3.6811. So let's see what that is. 20 minus 2b. 12.6376. 12.6376. And my height is just that number, 3.6811. And then the max volume is, and I just multiply these numbers, 1, 2, and 3. So I'm going to go this number times this number times B. 820.5281. 820.5281. Could you do it? Oh, this one needs units, unless they don't tell me what x is. Yeah, inches. Cubic inches. Cubic inches, guys. Could you have done this question without calculus? Yes. Do you guys want to see it without calculus? No, it's really simple. No, it really is. Look, if you were an algebra student, remember, isn't this the expression for volume right here, this one? Can't I just plot, guys, this gives me my volume for every x value. I already know that that the x value is between 0 and 10. So can't I just plot this equation in my calculator and see where it's the biggest? Yeah, and I bet you it's going to give you this one. Let's do it just to verify. By the way, this is my first time doing all these. So if for some reason it doesn't come out right, that means I just messed up. But I'm confident. I don't think I saw any mistakes. We're going to get the same x value. So watch. Give me the volume equation, guys, from scratch. 12x what? Squared or cubed? Oh. I thought it was cubed. No, it has to be 4x cubed. 4x cubed. 4x cubed. Minus 50 or 90? 90x squared plus 500x. Yeah, guys, relax. 0 to 10. And let's go from negative 10 to 1,000. Okay, check it out. There's a moment of truth. Nice, beautiful curve. I'm going to tell the calculator to give me my maximum. Second, calculate max, number 4. And I want it to look between here. So let me make sure. Bam. This is how an algebra student would do it. And here. I want to look between those two. And it says guess. Nah. Boom. Look at that. 3.6811 and 820.5281. Did we get the exact numbers?
Yeah.
Wasn't that cool?
Yep.
Oh, you guys don't think that's cool?
Not doing it that way.
All right, here we go. How do you guys feel? Do you think we can take some more or no?
What else is there to do?
We have that little one pager, but I haven't passed it out yet. I have it over here. It's this one right here.
I just don't want to.
All right.
How long do you think that's going to take?
This one, not too long. I think we'll understand it pretty quickly. Yeah, go ahead. All right. Let's read it. This one says you're designing a can. Oh, yes. Look, guys. Okay, I just wanted to model this. Do you guys, because I see it all the time, when you guys shop and you guys are looking at the drinks, do you guys ever see how companies are saying, oh, we're being eco-friendly, we're using 25% less plastic, but it holds the same volume? Do you think they're doing it to be eco-friendly? What are their motives? Profit. Profit. But
The
they,
least amount of plastic they use, the least amount of plastic they have. I was talking about this with someone.
yeah. See, so for you environmental engineers, I mean, don't get me wrong, you are helping the global world by using less plastic, but they're not necessarily because they're trying to be eco-friendly. They're trying to save money. So look at this design of this can. Do you think they just magically said, this is the design we want to use because this is the design we want? No, there's a reason why it has these little patterns. Look, all these little patterns, those indications, they save plastic. They save plastic. They could have easily made it real smooth, but they didn't. No, it's by design. Look, these caps, they used to be big. Now they're like, oh, now look how small they are. You think they're doing this on purpose? I mean, they are doing it on purpose, obviously, but are they doing it to save the planet? Oh, maybe, but they're probably doing it for money. And this is what this is about, guys. Look, you've been asked to design a 1-liter oil can shaped like a right circular cylinder. What dimensions will use the least material? Ooh, you need to know about. Dang, do you guys know the metric system?
No. But we can learn it.
Okay. All right. Let's skip this one temporarily. We are going to come back to it, though. Okay. I'm going to skip example 5 temporarily because there's a hack to it, and I don't want to show you the hack just yet until we get more experience. Example 6.
But that's like him telling us that we couldn't take the derivative first. We were just taking the limits.
Yeah, don't worry. It's not that type of hack where you're going to be like, oh, why can't we do that? It's a hack to make a derivative not so ugly. And it only works on all right, here we go. Example 6. A rectangular playground is to be fenced off and divided into 2 parts by a fence parallel to one side of the playground. 240 feet of fencing is used. Find the dimensions of the playground that will enclose the greatest total area. Look, what if this is your situation, guys? What if you have, I have enough money to buy 240 feet of fencing. What's the biggest rectangular area that you can make with that much fencing? So let's see what it is. So first, make a model. It doesn't matter how you make it. Make your model. I'm going to make my model here like that. Next, do you want your divider horizontally or vertical? It does not matter. You'll get the same answer. You'll just have your dimensions switch. Your x will be your y will be your x. Vertical? Okay, so I'm going to make my divider vertical. Bam, there it is. All right, next, start writing equations for your model. So this is fencing. This is how much I have. So I'm going to call my horizontal displacements, I'm going to call them x. My vertical displacements, I'm going to call them y. Bless you cube. Bless you squared. Bless you cube. All right. How much fencing do you have? 240. And all this is fencing, guys. All this is fencing. So I'm going to write how much let's do the horizontal. I have x plus x, so that's what? 2x. And how many y's do you have? And all that amount of fencing better add up to how much? 240. We're going to call that the restriction equation. Are we okay? Now, what are they trying to maximize? Are they trying to maximize the area? Yeah, find the dimensions of the playground that will enclose the greatest total area. They're trying to maximize the area. So how do I find area of a rectangle? Perfect. So, right, A equals, and I'm going to have x times y for the big, that gets you the most area. It doesn't matter about the divider where you put it. Cool or not cool?
Cool.
Okay, here we go. What am I going to take the derivative of? The one on the left or the one on the right? The expression on the left or the expression on the right? Well, what are you trying to maximize? So because I'm trying to maximize the area, I'm sorry. Yeah, maybe I'm the one. Maybe my wording is wrong, and I'm not very good at explaining. I'm trying to maximize the area, so the area is what I'm going to take a derivative of. Does that make sense? Perfect. So here we go. use the restrictive equation. You're not going to do product rule, at least not with this. You're going to simplify in terms of one of the letters. I like to take derivative with respect to x, so I'm going to solve for y on this one. So move the 2x to the right. So I'm going to write 3y equals 240 minus 2x. Oh, I don't like having a fraction, so I'm just going to do it like this. Divide by 3, divide by 3. Y equals, well, 3 does go into 240, nice, but, well, you guys tell me. Do you guys want it like this? Or do you guys want it 24? 3 goes into 24, is it 8 times? So 80 minus 2/3 x. Do you guys, which one do you want? This one, box number 1, or box number 2? Okay, box number 2 then. All right, here we go. I don't see any mistakes. I think everything is good. I'm going to plot this restrictive equation in terms of y. So my area equals x times 80 minus 2/3 x. Make sure that x does not hover below. Don't put it next to the 3. If you're going to put it in top or bottom, put it with the 2x over 3. I like to put 2/3 of x. Are we okay so far? Nothing crazy, right? You can do product rule if you want, but I think it's just easier just to multiply like that, guys. So I haven't done anything yet. I'm just doing algebra. 80x minus 2/3 x squared. Are we still okay? Now I'm going to take a derivative. You guys ready? A prime equals the derivative of 80x. 80 minus the derivative of 2/3 x squared. 4/3 x. Good. I'm going to equal this to 0. Oh, we can slow down before we continue. Because of my restriction, what did I delete? Okay, this is box number 2. Because of my restriction, let's see. Where are you? You know what? It doesn't matter. I'm going to say this. Because I only have so much fencing, if you only get one critical number, that is the critical number that gives you the max area. Because at both extremes, if I max out the x value, then I won't have a y value. So my area will be 0. If I max out my y value, then I won't have an x value. My x value will be 0. Does that make sense to you guys or no? Am I making any sense? Okay. So what I'm trying to say is this right here, look, this expression here, all this because of the 240. So maybe I can make, oh, okay. Okay, let's just continue. All right, here we go. All I'm doing is solving for x, guys. You're only going to get one critical number. 4/3 x equals 80, or 80 equals 4/3 x. Are we still okay? Yeah. Times 3 both sides, 4x, or times 3/4, but I'm doing it in 2 steps here. 8 times 3, what's that, 24? 240, and divide by 4. What's 240 divided by 4? Does it go nice? 6? Yeah, 60. So there it is. X is 60. It's the only critical number. Am I shocked that it's the only one? No, this is the one that gives you your max area, guys. It has to. It must. Okay, because x is 60, can I get my y now? Yes, I said that y was equal to 80 minus 2/3 of x. So y equals 80 minus 2/3 of 60. So y equals, let's see, 3 goes into 6 3 times, 2 times 3, 2 times, 3 goes into 2 times 2, 40, 80 minus 40, 40. Did I do that right? Okay. No, check, guys, because I'm pretty tired too.
Yeah, it is.
Okay.
Because we multiply 65 to get 120, and then 1 over 3 is 40, 80 minus 40.
Okay, so there it is. So my max area. What is 6 times 4? So 240, and I need units, square feet. So x is 60 feet. Y is 40 feet. So let's look for that. Which one is it? C. How do we feel? We feel okay? All right, one more and then we'll call it a day because I want you guys to see the business, you business people. Who are business majors here?
Oh, no, I am.
You're a business major? Okay.
She's like, I forgot.
Okay, man, I don't want, okay, remind me to erase this because I'm talking smack. There is a course at the university called Business Calculus. It's a joke. So don't, just because it has the name Business Calculus on it, like, oh my God. For those math teachers, they're like, oh yeah, I took Business Calculus. I know calculus. If you took Business Cal, you don't know Cal. Business Calculus is watered down calculus. This is about as hard as Business Calculus gets. This right here. So this is a Business Calculus question. Cool? This is how you would use it. If you're a business major, when you become a business, you're going to see all you're doing is making models to make predictions. This is what you do in Business Calculus. All right, let's see if we can do it, guys. So look, you're a manager for a company that's making goods or products. Look what it says. The average cost function A of X is defined by the cost divided by X, where C of X is the cost of function and is the cost function, and X is the number of units produced. Well, yeah, that's how you get the average cost. The total cost divided by how many units you produced. It's the average cost per item. Does that make sense? Focus, Lavelle. Focus real quick. Find the production level to minimize the average cost. So now look, check it out, guys. You are finding the exact number of units that you have to make to bring the cost down to the lowest possible per unit. Because there is a number. If there is. There's not always a number. If there is a number. So you're the boss. You're the engineer. You're the one that's having to decide like how many to produce. Because as soon as you start making more than that, now it starts costing you more money. Does that make sense? Isn't this exciting? You're not excited for, like, look at all this knowledge that you're getting, guys. Okay, so check it out. Check it out, guys. So do we understand, like, okay, here was the hard part. They gave it to you. This is why I'm telling you that this can be very hard very easily. Do you understand where this equation came from? No? The A stands for average cost. The C is just how much it costs. And the X is how many units you produce. So if you want to know the average cost per one of these, isn't that how you find average cost? Like you find the total number that it costs to produce and you divide by how many you produce? And that's going to give you the average cost of one. Would you be able to come up with that equation on your own? Yes, that's what I'm trying to get to. Like we gave it to you here, but can you come up with it on your own in the future? Okay, so here we go. What am I trying to minimize? I'm trying to minimize average cost. So that is what I'm going to take a derivative of. Do we understand? All right, so here we go. A of X equals, I'm going to write what C of X is, 25000. This is real stuff, guys. So that 25000 probably means 25,000. That's probably the initial investment. Plus 100X plus the 4X to the 3/2. That's probably like the waste. All divided by X number of units. Are we okay? All right. Let's see, what do I want to do? Do I want to do quotient or do I want to divide each term? What do you guys want to do? Do you guys want to divide each term by X so we can eliminate the 100X, the X there, and eliminate one of the X's and the X to the 3/2? Or we can just go right into quotient rule. Right into quotient rule? All right. A of X, A prime of X, or A prime. Bottom. It's time to rid of the top. What's rid of the top?
100
Yes, 6X to the 1/2. Plus or minus? Minus top 25000 plus 100X plus 4X to the 3/2 times rid of the bottom, which is just 1 all over bottom squared. Are we okay or no? Let's see if it's a nice and pretty number, or if it's not, we'll just use our calculator. A prime of X, let's see. 100X plus 6X to the 3/2. Does everyone know what I'm doing? I just distributed. Minus, I'm distributing this negative. 25000 minus 100X. Ooh, yeah. Minus 4X to the 3/2. All this is over X squared. I see some stuff that zeroes out. What zeroes out? Bam, bam. Let's see. And then combine them. So 2X to the 3/2. X to the 3/2 minus 25000 all over for x squared. And I'm going to equal this to what? 0. So I don't have to worry about the denominator. You just worry about the numerator. 2x to the 3 halves equals, well, I guess I should show the steps. 2x minus 25000 equals 0. Move the 25,000 to the other side. 2x to the 3 halves equals 25,000. Divide by 2. X to the 3 halves equals 25,000 divided by 2. Is that 12,500? And then either raise it to the 2/3 or take the square root and then raise it. Did I say square root? Take the cube root and then square it. Right? 3 halves raised to the 2/3 will be x. Oh man. Okay, side note. If I have x to the 3 halves equals, I don't know, let's say a. How do I get x by itself? You either raise it to the 2/3, because remember an exponent raised to an exponent, you multiply it and you get a 1. So whatever you do to one side, you do to the other. So you either do that, or it's funny how are you guys okay? And you guys like, or you can do this. X to the 3 halves equals a. You can go square and square, and that will take out the square root. So then you have x cubed equals a squared, and then cube root. See? So x equals cube root of a squared, which is the same thing as a to the 2/3. That's a side note. All right, so let's see. I take my calculator. I don't know if that's a pretty number. I think it is a pretty number. 12,500 raised to the 2/3. It feels like it's a pretty number. It feels like it's a pretty number because of the 12,500. 12,500 caret 2/3. It's not a pretty number. Oh, you know what? Let me make sure. No, it is. I think we got it right. Caret, and then use the alpha feature so I don't mess up. 2 in the top, 3 in the bottom. Nope. Yeah. 538. What is it? 538.6086. Oh, okay. Here comes the question. The business question. 6086. Can you make point something of a product? No. Are you going to round it up or are you going to round it down? Round it down. Good job.
Yay.
Make 538. 530. Yeah, the 0.6 you're running. Make 538. Make 538 units. Cool, right? Or you guys don't like this stuff?
I like it.
Okay, I'm gonna go ahead and give you guys this. It's not due today, but you can do. Let's see. Actually, you know how to do all of them. Let me pause this. Do you guys have your example 4 there? Example 4.
Let me rearrange first. Hold on.
Oh, you know what? Let me tell you guys. I think I already did, but just in. Yeah, it's already open. So there's one up there already. We'll put a second one up there later on. I think I put like a whole week for the progress check one. All right, here we go. Designing a can. You have been asked to design a 1 liter. 1 liter oil can shaped like a right circular cylinder. So hopefully you know what a right circular cylinder is. This is how they used to have oil cans in the 50s. What dimensions will use the least material? No longer do oil cans come like that, by the way. Now they come shaped kind of rectangular. All right. You guys ready? We can't do this question unless you know conversions. And it's not even extreme conversions. So 1 liter is equal to how many cubic centimeters? Do you guys remember or no? 1,000 cubic centimeters. I think 1 cubic millimeter is equal to 1 cubic centimeter. Or 1 cubic millimeter or 1 cubic centimeter. So there it is. Make sure you know the metric system: kilo, hecto, deca, base, deci, centi, milli. At the very minimum, know that. There's also mega and micro and pico and all those. But at least know these, and then you should be good. All right, here we go. You guys ready? So first, let's see, what do we know? We know that this is my volume. So what is the equation for volume of a right circular cylinder? Well, volume is equal to, I need the area of that base, pi r squared, and then I gotta multiply by the height. And that will give me that three-dimensional space of volume. Does that make sense? So pi r squared and then times h will give me that third dimension. All right, so I can say 1,000 equals pi r squared h. Bless you, 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 bless you to the fifth power, bless you to the sixth power. Oh, new record. All right. Oh, we're okay though. Okay. The area. They don't give you the area equation. That's the hard part, getting a model for this. So what would be the model for the surface area of this? So let's see. I have a top and a bottom of the can. So the bottom of the can and the top of the can are shaped like what shape? A circle. What's the area of a circle? Pi r squared, and I put a 2 in the front because the top and the bottom. So this is the top and bottom. Top and bottom. Plus, now I need the wall. The wall of this can, if I were to cut it and shape it out, would look like this, where this is your H. And all this distance right here in sky blue, all that distance is what? Not the diameter, you're close. The circumference. What is circumference of a circle? 2 pi r. 2 pi r is the circumference of a circle. So what will give me that area? 2 pi r times height. This is the wall of the can. Does that make sense? Okay. What are you trying to maximize or minimize? The least material, so which deals with which one? Volume or area? Area. So we want to minimize this. Of course, there's something called like density and waste and all that, but we're rookies, so we're just doing the basics. This is what we want to minimize. So that is what I'm going to take a derivative of. Now, you see how you have two variables at the moment? You have r and you have h. You don't want to deal with two variables. I mean, you can do the product rule, but it just makes things more complicated. So how do you make it in terms of one equation or one variable? By using the restriction equation to get it in terms of one. Does that make sense? So I take this, and you can choose whichever letter you want. I see it, and I think I want to use R. Child, why do you want to use R? Because I see R here, and I see R here. So I think it's easy if I just replace the H. Does that make sense? So that's how you should be thinking. So it's really simple to get this in terms of just R, like H equals something in terms of R. So I just divide both sides by pi r squared. So H equals 1,000 divided by pi r squared. Are we okay? All right, so here we go. I'm going to write area equals 2 pi r squared plus 2 pi r parenthesis 1,000 over pi r squared close. And I'm going to fix it. Equals, let's see, the 2 pi r in the front is the 2 pi r squared in the front is just 2 pi r squared, so leave that alone. Plus, let's see, what do we got here? 1,000 times 2, what is that? 2,000? And then I have a pi, and then one of those r's cancel out, so I have the r in the bottom. So I have it like that.
Why don't the pies cancel out?
Oh yeah, the pies do cancel out. I didn't even see it. The pies cancel out. I didn't even recognize it. I'm sure I would have hopefully recognized it after I look at it again. How do we feel so far? Okay. From there, this is what I want to minimize. This is what I'm going to take a derivative of. So I go a prime equals, let's see, 2 pi r squared. So that's going to be 4 pi r. I'm taking the derivative with respect to r. So there is no drdt or anything like that. Minus 2,000 over r squared. I hope that we can see that real quick without having to do a side note. Okay, I'll do a side note. 2000 r negative 1. So when you take the derivative, negative 2000 r negative 2. So that's where the r squared comes. Okay. Are we okay right now? I'm going to equal this to what? 0. I'm finding a critical number. So now I'm going to move this expression to the right. Get it? I'm moving it to the right. So for no, hey, stop. Like that way we can. Okay, well we're good now, right? 2000 over r squared. No, we're good. We're good, miss. We're good. Are we still okay? Times r squared both sides. So we're gonna have 4 pi r cubed equals 2000. We're going to divide both sides by, I guess you can divide both sides by 4 pi. 4 pi, 4 pi. Let's see if we can do this mentally. 4 goes into 2000 5 times, so 500. 500 over pi. And the last thing I got to do is take a cube root. Either raise it to the 1/3 or do that, cube root like that. So r equals, here's the exact answer, 500 over pi, which is approximately, let me write the decimal digit. I'm going to take my calculator, and I'm going to put a little fraction. 500 over pi, raise it to the 1/3. There's another way to do it. You don't have to do it like this. Let's see if I can connect it here. Yep. I wanted to use my calculator here, but okay. All right. If you do math and you do number 5, you can also do cube root of what you guys just did. 500 divided by pi. What Guerrero just told us.
You can also click 4 because that's automatically.
Yeah. You go. Oh yeah. 4 gives you the automatic cube root. Look at all these different ways your calculator can do. A whole bunch of different ways. All right. I'm gonna store this to A. I like to go down the alphabet. Alpha A. 5.4192. That's truncated. 5.41926. I'm going to do it all the way there. 5.41926. Okay, now here comes the question. How do I know that this is a min and not a max? Because in this case, R, I can use up, as this one is not restricted, I can use up as much R, as much material as I want to use. How do I know that's a min and not a max? And before you say, well, do the first derivative test to see if it changes from positive to negative or negative to positive. And I guess we could do that. We do have a derivative expression, and we could check to see if it changes from positive to negative, negative to positive. But there's another method that I think is easier. If this is my critical number, if it is the only critical number, only critical. Now, just because it's the only critical doesn't mean that that's an automatic max. It's not a max. It's only a max if my extremes are 0. Then that's the only one that gives me an answer, right? That would be for a max. For a min, 0 would be min, so it won't work to do that test. Plus, I can use as much material as I want. To check if this is an absolute min, if I do my second derivative test and I see that my second derivative is always concave up, if you're always concave up, then that critical number must be a min. Think about what I just said. If you're always concave up, then that critical number must be a min because you look like I don't want to say parabola because it's not a parabola, but you have that shape. Something's opening upward, some function's opening upward, and that critical point is the lowest point because it equals 0. So that means you have a horizontal tangent. So that means that horizontal tangent has to be a min on that original function. Does that make sense? So that's what I'm going to do. I'm going to prove that the second derivative is always positive. So I'm going to go a prime prime equals, and let me zoom in. So the derivative of 4 pi r is just 4 pi. We still okay? And then let's see, 2000 r to the negative 2. So 2000 times 2, 4000. And then I subtract 1 from the negative 2, so that's going to be to the third power like that. Notice, and I'm going to write, comma, since r is always positive, comma, a prime prime will always be positive. Hence, comma, r equals 5.41926 will produce absolute minimum area. There it is. We found our dimensions. Well, almost. We just have the radius, but we'll get the height right now. Are we okay? Now that I know my radius, all I got to do is plug this into my equation for height, and you'll get your height. Chav, what is the equation for height? We did it right here. 1,000 divided by pi r squared. So to get the height, I go 1,000 divided by pi times my a value squared. Saved in calculator. Ooh, I got to be careful because a stands for area. Maybe I should have used b. Saved in calculator. All right, I take my calculator. Okay, here's where I got to tell you guys to be very careful. If you do this, tell me why this is wrong. Tell me why that's wrong.
Because it's squared the square of pi and a, not just a.
This is 1,000 divided by, oh, I put 100. Well, that's wrong too. But if I were to put a 0 in front of this, there we go. It looks right. It looks right. You have the right idea. But guys, especially those of you that are learning to code, those that are a computer science major, you got to learn how computers work, how computers execute. When you tell the computer to do this, it does a line at a time. It doesn't know. It thinks the computer thinks this. You're doing 1,000 divided by pi, so it executes that. Boom, and then it says whatever that is multiplied by a squared. Does that make sense? So how do I fix this? Well, you either use parentheses. So either you come back and I'm going to put second insert, and then I'm going to, come on, buddy. Second insert parenthesis, and then put close, not that guy. I don't care about that. The 1,000. I care about the pi a squared. Second insert parenthesis, and then close it off right here. Either do this. That's the correct answer. Or to never make a mistake, if you never want to make a mistake, just use a little fraction feature. 1,000, I can't, small fingers. 1,000 divided by second pi alpha a squared. And then look, there it is, same thing. Cool or not cool? Okay, so make sure, write that down somewhere. 10.8385. Eight, 3, 8, 5. And I need units. If you are working with units, put units. Centimeters. 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 I'm actually curious to see this graph. I want to see it. I want to see this graph. This one. Let's see it. I want to see it, guys. Let's see it. Y equals. Hook me up with the equation. What was it? The original, the area? With the r's? 2 pi x squared. And then it was plus, right?
Yeah.
Plus alpha fraction. Oh no, give it to me with r's.
Oh, 2 pi r and then 1,000 over pi r squared.
2 pi x and then.
Oh no, that was on the. Never mind. Someone else.
2,000 over r. Got it. Sorry, miss.
No, my bad.
Maybe you did say 2,000 over r and I just didn't catch it.
No, I didn't.
Oh, my bad. You sounded so defeated, miss. Like, no, I didn't. 2,000. I'm curious to see this concavity here over x. Okay, window. Obviously, I'm working 0 to 10 is fine. Y min, -10. Y max. This is area. What was my area?
I don't know what numbers to put. Yeah. That's why
Okay. Did they want to know what the shape? Oh, okay. You know what? I don't know what this area is. Let's find out what that area is really quick before I put my scale here. This is my h. Okay, now give me the original with the h. So it was 2. Give me the original equation with 2 pi r squared. So I have it in a squared plus 2 pi a h. Okay, so h is this one right here. I guess I could have also used the other one. My bad. Times that. All right, let's see if it executes. Okay, let's. It would have worked also if I would have done. I think. Look, 2 pi alpha a squared plus 2,000 divided by a. Yeah. Okay. Check it out, guys. Let's see. Now I know what my y value should be. So I'm gonna do my y scale here. So look. Let's see if we get a nice graph, and let's see if it really is the absolute minimum. Window. Y max, let's go to 800. And then Y scale 100. Okay, graph. Yeah, look at that. I want to see it better. So let's go to 1500 and graph. Wow, now you can definitely see that is definitely, and this goes up forever. So you know what? Let's make the X value a little bigger. 20. Look, check it out. There we go. Now you can definitely see it. Is that definitely an absolute min down there? There's my radius, by the way. Let's see. Second, calculate. If you were an algebra student, you would just say, oh, let's just find the minimum. Minimum, and I'm going to go all the way. Let's make sure that, look, like this. Enter. And then let's go past it. And then let's go a little bit up. And then this is not using calculus. It's just algebra, right? Guess. Look at that. Is my R 5.419? There it is. That's my R value that will give me the smallest amount of surface area. So if you were designing a can that holds 1 liter and you want to make the most money possible, you would design a can that has this radius and that height, and that would maximize your profits because you're using the least amount of material. Does that make sense? Cool, right? Okay, so now let's do the hack question. What was my absolute surface area minimum?
500.
Min surface area is 553.58104, and then units. It's area.
Oh,
Squared. Say it again. Yeah, this is a tough question. This is about as hard as it gets. Look at all this beautiful math. You guys don't like all that beautiful math? I think it looks amazing. All right, we're going to do a hack. Relax. This is a UH question. I do the hack also on your UH quiz when you log in. I think there might be 2 versions of this. It says, find the coordinates of the point on the curve, y equals square root of x plus 4. So here's the first thing you got to know is, do you know how to graph that? That's just a square root curve, the square root of x, shifted 4 times to the left. So it starts over here at -4. That's my endpoint. And it looks something like that. 2. And that you just got to know, guys. That's just from algebra. Cool or not cool? All right. It wants, look what it says. Find the coordinate of the points on the curve. So I want a point on this curve that is closest to the point 70. I'm just going to say 70 is over here, not to scale. So what is it asking of me? It asks this, like, is the point over here? I'm just making this up. The point is not way over there. Is this the point that has that is the closest to 0.70? Is it this point? Is it this point? Is it this point? You know what? Let me extend. Oh, it's fine. Is it this point right here? Like, which one is it? Like, it could be any point on this curve. So do we understand the question? So they want the shortest, if I call this distance, they want the shortest distance. Cool or not cool? So here's what you do. Don't worry, we're going to do a hack. The first thing that should be going through your through your mind, is distance formula or quadratic or Pythagorean theorem. They're both the same. So here we go. D squared equals the change in x squared. So I'm going to use delta x plus the change in y squared. And then to get d by itself, you would do the square root. So you would go d equals the square root of the change in x squared plus the change in y squared. Okay. And then this is what I want to minimize. So this is what you would take a derivative. Now here's the problem. It will work. It will. If you have software like MATLAB or Maple, you would just type it in and say derivative of that expression. It will just give it to you and you'll get the exponent immediately. It will work. But if you try to do the derivative of this, it gets nasty really fast. Why does it get nasty? Because of the square roots, because of chain rule. You'd have to do that, because you'd have to do this. Change in x squared plus, you have to do like chain rule twice. So check it out. You would go bring the 1/2. You would bring the 1/2 to the front. You would bring the 1/2 to the front and then leave the inside alone. And then you got to take the derivative of the inside, which is again chain rule. And then leave that inside alone, have the derivative of the inside. Do you guys see how that? Yeah. So here's the hack. So it'll save you so much time. Okay, relax. I need everyone to focus on this one really fast. This is what you're trying to minimize. All you care about is minimizing the expression. What does it matter that there's a square root? As long as you get the inside of that square root, aren't you trying to minimize the inside of square? Like, if the inside is small, the square root of that will be even smaller, no? So you can just get rid of the square root because all you care about is getting the expression as small as possible. This doesn't work for everything. This works for this because the math works out because of the logic. Well, if I'm trying to find the minimum, it's the square root of that. Can't I just find the smallest for that expression because I'm taking the square root of that expression anyways? Does that make sense to you guys? Yeah. So it only works for this one. Don't be trying that on other stuff with square roots because it depends on the context. It only works for this because we're trying to get the smallest expression possible, and it just so happens that there's a square root on it. Square root of that expression is going to be even smaller. Does that make sense? Yeah. So don't be doing this hack for other stuff that there's a square root. Oh, there's a square root, I'm going to do the hack. Don't. Just for this scenario. Cool or not cool? Okay, so here we go. I'm going to plug in. I'm going to, look. All right. Here we go, guys. Here we go. So this is some x value. I don't know what that x value is, and some y value. And that y value is dictated by this. Do you guys see that? Yeah. So this coordinate, I'm going to write this coordinate over here. That coordinate is x comma square root of x plus 4 if you want your coordinate in terms of x. You all right, Espinosa? Yeah. Are we cool right now, guys? Okay. No, don't worry. We're gonna be doing some simple stuff. I'm gonna write d equals, and I'm not gonna write the square root. I'm gonna write parenthesis the change in x squared. Well, this coordinate is 7, so I'm gonna write 7 minus x. In case you're wondering, change in x just means x2 minus x1. Change in y just means y2 minus y1. I'm calling this my x2. I'm calling this my y2. And I'm calling this one my quote-unquote x1. And I'm calling this one my quote-unquote y1. Cool? Okay. 7 minus x. Maybe I should have done x minus 7. Okay, too bad. I already did it. Plus parenthesis. And I'm going to write, what am I going to write? I'm going to write 0. Yeah, I should have. It doesn't matter. We'll get the same thing. Square root of x plus 4. Close it squared. Are we okay? Yes. All right. Now let's go ahead and take a derivative. You know what? Maybe I would simplify it first. D equals, do you want to expand this or leave it alone? Doesn't matter. It's the same. We can leave it alone if you want. Leave it alone. 7 minus x, close it squared. But this one I'm not going to leave alone. Plus, when you square a negative, does the negative go away? Yes. So you just have x plus 4. Now I'm ready to take a derivative. D prime equals the derivative of this, chain rule, 2, parentheses 7 minus x, close it, and then don't forget, times what? Negative 1, correct? Plus, what's the derivative of x plus 4? 1. We're going to equal this to 0, but let's simplify it first with that negative, so don't forget. So negative 14 plus 2x, let me know if I made a mistake, plus 1, so let's see, it looks like we got, let me rewrite it, 2x minus 13. Are we all right? Okay. I'm going to equal this to what? 0. So then that means I have 2x equals 13. So that means x equals 13 over 2. This is the one that's going to give me my smallest value. And if you want, you can already just look at your answer choices and you can already see there's only one with 13 over 2. What's the answer? C. We're going to get the y value. Yeah, 13.2 is like you're somewhere. It's like somewhere over here, and this is like the smallest point right there. That's closest to the 0.70. All right. Yeah, I know. So, oh yeah, maybe you're right. You can just look at the answer choices and be like, But what if there were two answers that had 13.2? How did they get the y value, guys? Plug it in. You plug it in. Look, guys, y equals square root of 13 over 2 plus 4. I'm going to turn that 4 into 8 over 2. That's the same thing as 8 over 2, right? 4. Third, so square root 13 and 8. What's that? 21 over 2. So then I have square root of 21 over square root of 2. And then multiply. What are you talking about? I want to multiply by square root of 2 over square root of 2. So square root of 21 times 2 is 42. And then square root of 2 times square root of 2 is 2. So look, my y value is square root of 42 over 2. Is that what they have over there?
Yep.
All right. There is one question on UH that probably will make you do it, like make you find the y value, and one question that's not at 7-0. But this is how you do all of them. Cool or not cool? So there it is. We've done all of them. I think we have enough experience for everything now. Let's get the handout out of the way. And then I'll give you a circuit for you guys to do. Let's see how much we can do on that. And then the circuit will redo Monday. What's up?
Wow, look at you.
So when you multiply the square root of 2 over square root of 2, why does the square root of 2 become just 2, but it cancels out? Oh wait.
Because the tops have the square root of 21 times.
I set up a petty 14.
Well, you can always ask, miss. Ask.